Welcome to this video tutorial on xlminer, the data mining add-in for Microsoft Excel. In this tutorial, we will learn how to use the data utilities tools provided in xlminer. xlminer provides us with a host of data utilities at its disposal. They are sample data, missing data handling, bin continuous data, and transform categorical data. We will look at how to use each of these tools one by one, starting with sample from a worksheet. When huge amounts of data are involved, statisticians prefer taking a sample of the data that represents the entire database. However, such a representative sample is very difficult to obtain. The entire dataset we want information about is called the population. A sample is a part of the population that we actually examine to draw conclusions. A good sample should be true representation of data. As far as possible, the cases chosen for sample should be like the cases that are not chosen. If the sample design is poor, it can produce misleading conclusions. Various methods and techniques are developed to ensure a true sample. xlminer provides it with different sampling facilities. 1. You can create a simple random sample. That is, a random sample of X records is chosen from the data such that every record in the sample has an equal chance of being chosen. Or, you can either create a stratified sample, where the data is divided into strata of similar items. Then each stratum is sampled using this simple random approach, and the results are then combined to give a final sample. Let us look at how to create a simple random sample. First, we select a data source which we wish to partition. We can select any of the data sources that are provided as sample data along with the xlminer or a data source at hand. Here we select the wine.xls sample data source. In order to partition data, we click on Partition Data and select Standard Partition. Here we have to select the variables that we wish to view in our output. We select all the variables and then we have different options here. Automatic, Start. Let us select the wine.xls sample data source. In order to create a sample, we click on Data Utilities and then Sample from Worksheet. A new wizard is opened. Here we select the variables that we wish to have in our output. Let us select all the variables and then click on this button. Once the variables have been selected, we have different options. The sample with replacement option, if checked, the data is sampled with replacement. The default is sampling without replacement. You can also set a seed. The user can enter a sorting seed. The default seed is 1, 2, 3, 4, 5. We can change it if we wish. Let us change it to 1, 2, 5, 6, 7. Let us select a simple random sampling option. We will look at stratified random sampling later. Once a simple random sampling option is selected, click on OK and the xlminer creates the sample. We can see that a sample of 54 records has been created and the records selected in this sample have been randomly chosen from the entire data set provided. So this is how we create a simple random sample. Let us now look at how to create a stratified sample. We can also create a simple random sampling along with a replacement. Here let us check the sample with replacement option, select all the variables, set a sample size as 50 and click on OK. The sample is being created with replacement. We can see that in the output where we have selected without replacement, none of the records have been duplicated, whereas in this option where we selected sample with replacement, you can see a few records such as 94 or others such as 69 have duplicates present in the dataset. This is how the output is different when we select sample with replacement option. Let us now look at how to create a stratified random. To create a stratified sample, we select the sample from worksheet where we select stratified random sampling option. On selecting this option, more options are visible. First, we select all the variables that we wish to be present in the output and then set the size of the sample as 50. Here also you can either use the option as sample with replacement or you can wish to uncheck this option. Let us look at the different options available when we select the Stratify random sampling. The Stratum Variable option gives a list of variables from which the user can decide which to use for stratified random sampling. Note that xlminer allows only those variables which have less than 30 distinct values. As the user selects the variable name, xlminer displays the number of strata that a variable contains in a box in front of the smallest stratum size, in front of the option equal from each stratum, number of records equal to smallest stratum size. Let us select one of the options as alcohol. Here we can see that the selected option or the stratum variable has more than 30 distinct values and hence cannot be selected. We click on OK and then select a different stratum variable. Let us select the type option or the variable type variable as a stratum variable. You can see that this variable contains 3 distinct values. We can either select the stratum to contain a proportionate sample of this stratum or equal from each stratum, where we can specify the number of records of each stratum to be available in the sample. Let us first select the proportionate to stratum size and then click on OK. Selecting the proportionate to sample size, xlminer start. After selecting the stratum variable, we have to select how the sample is to be created. Selecting the proportionate to stratum size causes xlminer to detect the proportion of each stratum dataset and maintain the same in the sampling set. Due to this, xlminer sometimes has to change the desired sample size on the higher side in order to maintain the proportionate stratum size. xlminer then displays the actual sample size in the output along with the desired sample size as shown in the output. Let us select the proportionate to stratum size and then click on OK. You can see that the sample is being created. Here in the output, you can view how the percentage of records in the input data has been kept same as the percentage of records in the sample data. The total number of records in the sample data are 17. So we can see 17 of class A, 17 of type, 20 of type B and 14 of type C. So you can see that we have created a sample using the type variable as a stratification variable. Let us now look at how to create a stratified sample with equal number of records from each stratum. Here we have 17, 20 and 14 records from A, B and C stratums respectively. We select the sample from worksheet option, click on stratified random sampling and then click on the equal from each stratum. On specifying the number of records, the xlminer tool generates sample which has the same number of records from each stratum. In this case, the number chosen automatically decides the sample size, so the option to be entered the desired sample size is not available. Let us select 20 records to be selected from each stratum. We have to select the input variables and then click on OK. After selecting the input variables, we select a stratum variable and then click on OK. we can see that the percentage of records in the input data are 33%, 39% and 26% of each type A, B and C respectively, but in the sample data they have an equal percentage of 33.33% each and have 20 records each. So you can see how you have created a stratified sample which contains equal number of records from each stratum. Let us now look at creating a stratified sampling which contains equal number from each stratum and the number of records in each stratum is equal to the smallest stratum size. To do this, we select the data and then select Sample from Worksheet. Click on Stratified Sampling, select the input variables and then select the stratum variable. After all the selections have been made, we click on Equal from each stratum. Number of records equal to smallest stratum size. You can see that xlminer automatically displays the number of records in the smallest stratum. We click on OK to create the sample. You can see that each of the stratum contains 48 variables each, that is equal to the number of records contained in the entire data set of the type C, which is having the least percentage, that is 26.97% of representation in the input data. This is how we create a sample in which we can decide the percentage or the representation of a certain variable of interest in the sample data, so that the mining model so created can be created according to our requirement. This is how we create a sample that is used to create the mining models. Let us now look at missing data handling tool in the data utility. This utility allows the user to process the data before any mining model is applied on it. It allows the user to detect the missing values in the data and handle them the way user wants to. xlminer considers a cell to be missing data if it is empty or contains an invalid formula. xlminer can be prompted to treat a cell to be missing data if it contains a certain value specified by the user. The user can specify how xlminer should correct these missing values. A treatment can be assigned for every variable. The records with the missing data can be either deleted fully or the missing values can be replaced. xlminer provides options on how to replace the missing data, example by mean or median or mode or a value specified by the user. The available options depend on the type of variable. Let us choose a data set which contains invalid options or missing data cells and then use the missing data handling tool to make the data source more consistent. Select Data Utilities and Missing Data Handling tool. A new wizard is opened. Let us look at the various options available here. How are missing values coded in the data? Here, clicking this opens a dialog box. Clicking it, you can specify a value here. Whenever it appears in the dataset, it will be treated as a missing value and handled as per our instruction on missing value treatment. Check the box and enter the value if required. Clicking on the Override Existing Worksheet tool option makes the tool to override the existing worksheet. If it is unchecked, a new worksheet is created that contains the corrected data. Checking the variable names in the first row option tells the wizard that the first row of the dataset contains the name of the variables. As soon as we select this, we can see how the variable names are visible. Now, you can click on each of the variables and select a treatment to be done wherever missing data is encountered. We can see that there are different options available, such as no treatment, delete record, mode, mean, median and user specified value. Let us select the variable 1 option and then select user specified value and then click on 10 to be applied wherever the data is missing. Click on apply this option to the selected variable in order to save your setting. We select the second variable and then we see that the number of options have changed. It is because of the type of data available, which is character data. We can click on user specified data and then click on NAME to be the default value. Click on apply this option and then finally the third and the last variable where we will select the missing value to be replaced by the mean of the entire values. After selecting the actions to be taken wherever missing values are encountered, we click on OK. xlminer is creating the edited version. You can see that the variables whose values have been changed have been highlighted. You can see that in the dataset, the 7th row was having no data in variable 1, which has been replaced by the number 10 as specified by us, and these values have been replaced by the name as specified by us. You can also see that the 2 rows in variable 3 have been replaced by the mean of the entire set, that is 47.3. This is how we can make our data more consistent and handle the missing data. Let us now look at Transform Categorical Data tool available in xlminer. Sometimes our data sets may contain variables that take non-numeric values. This makes it difficult to apply standard procedures on such data sets. Hence, xlminer provides us with a tool which can be used to rename or transform non-numeric data to numeric data. There are 2 ways to transform categorical data. First, creating dummies. Consider the variable to have 4 distinct values as A, B, C and D. Then 3 rows named value 1, value 2 and value 3 are created with values either 1 or 0. If row 1 contains the value A and the value VAL1 will have a value 1, whereas the rest will have 0. If all the 3 rows have values as 0, then it is clear that the variable had a value D. You can also create a category score where in each of the non-numeric holds 4 distinct values as above. Each value ordered alphabetically will be numbered from 1 to 4, and a new column is created that contains the value of the number the non-numeric variable corresponds to. Let us see how to transform categorical data within our dataset. Let us select the irsfactor.xls sample data available with our xlminer tool in order to test the transform into categorical data option. Here you can see that all the columns except the species name contain numeric data, while the species name column contains non-numeric data. Now we will use the transform categorical data tool to convert the species name column into a column containing numeric data. In order to do that, we click on data utilities and then transform categorical data. Let us first choose the create dummies option, and then we shall later look at create category scores. Clicking on the create dummies option opens a new dialog box which contains the variables which have to be categorized or transformed. We will select the row or column name, species name, which contains the non-numeric data, and then click on OK. You can see that a table has been created containing the data which has been specified. You can see that 3 new rows have been created with numerical data as 1 and 0. 1 represents that certain particular row belongs to the class. that is named by as the row. Here species name Celosa is the column in which row 1 has a value 1. It means that the row 1 belongs to the species Setosa, whereas the fourth row belongs to the species Virginica. This is how we have transformed the non-numerical data in the species name column into numeric data. Let us use the create category scores option on this data. Click on the first row contains header start. We select the species name and then we can either assign numbers from 1, 2 or 3 or assign numbers from 0, 1, 2 and so on. We click on assign numbers starting from 1 and then click on OK. We can see that a new column species name or ordinate has been created that contains numerical data. You can see how Setosa corresponds to the number 1, Virginica corresponds to the number 2 and Versicolor corresponds to the number 3 as the category scores. So since 1 is the row ID, 1 belongs to the category Setosa, it has been given species name ordinate as 1 and the fourth row belongs to the class Virginica and hence been given a species name ordinate as 2. This is how we created a category score for each of the variables and converted the species name which contains non-numeric data to a column that contains the numeric data. This is how we convert our data to be more consistent and the regular mining procedures can easily be applied. This is how we use the data utilities tool in xlminer. For more presentations or tutorial videos on data mining, please visit dataminingtools.net. Thank you.